solving equations using GEMDAS, and here we have an example of a bunch of fractions. The nice thing is both fractions have variables, the same variable, so they both have n. So if the fractions are the same, then we can add these two terms together. So the issue is we have a 7 over here, and we have a 2 over here. And in order to add them, have to be the same. So we have to think of what's the common denominator between 7 and 2. The easiest way to figure out what the common denominator is just to multiply the two things together. So here we got 14. Oh, sorry, I gave you the answer. 7 times 2, that's equal to 14. So we know that our common denominator between 2 and 7, we're trying to get it to be 14. So how do we make 2 become 14? Well, we have to multiply it by 7. So what we do is we multiply both the numerator and the denominator by 7. So 7 times 1 is 7. 7 times 2 is 14. And we still bring down the n. This doesn't change the value because 7 divided by 14 still reduces to 1/2. So this still means 1/2. It just looks different. Bring down our plus sign. And now we have 12 over 7. How do we make 7 become 14? We have to multiply by 2 over 2. So 2 times 12 is 24. 2 times 7 is 14. And we can bring down the n. We haven't done anything with this right side yet, but we're still working with the left side, trying to get it to be, trying to get that to one term. So when we add fractions together, because they're common, because they both have an n, we can add the coefficients. Our denominator is 14. When we add, we just leave the denominator alone. So the denominator just stays 14. And then we add the numerators. So 24 plus 7 is 31. And they both had the term n, so we could leave the term n there. Now we can look at what happens when we bring in our solution. Okay, at this point, we're ready to start solving. Right here, we were just combining like terms, but now we're ready to use GEMDAS to figure out what the value of n should be. So we're working backwards. We look for addition and subtraction. Do we have any addition and subtraction? No, we don't. Okay, next thing, we come to multiplication and division. So here, it's a combination of the two. We are multiplying n by 31, but we're also dividing by 14. Another way to look at it is we're saying we're multiplying by the fraction of 31 over 14. So here we have the property that we talked about is the multiplication inverse, or multiplicative inverse. So if we want the coefficient in front of n1, if we multiply this by the reciprocal, 14 over 31, our 14 is in the numerator, our 14 is in the denominator, that will cancel. And our 31 is in the denominator, and our 31 is in the numerator, that will cancel. And what that ends up being is 1 over n. So what did we actually multiply to the left side? we multiplied the reciprocal of what was in front of the n. So we have to do the same thing on the right side. We have to multiply by the reciprocal, or the same thing that we did over here, which is 14 over 31. So for this one, we may recognize that 14 and 35 are both divisible by 7, because those are multiplication tables that we have, and we might be able to simplify it a little bit. But if we don't recognize that, we can just multiply across, and this is going to be a big number. So 372 times 14 is equal to 5,208. And 35 times 31 is equal to 1,085. This may have been a bad example. Now, we could, if we left it like this, I wouldn't be mad at you if you got it to this fraction and you said, I'm not sure what to do. But one thing that I know for sure for both of these, that they're divisible by 7. So if I take 5,208 and divide it by 7, and I take 1,085 and I divide it by 7, and we can see what we get. So this is 744 in the numerator, and 1,085 divided by 7 is 155. And at this point, I'm not sure if that will reduce any further than that, but we can leave it as n is equal to 744 over 155.